Today's topic is pointers. A pointer is a variable that represents the location of a data item. They have a number of useful applications. They enable us to access a variable that is defined outside the function. They can be used to pass information back and forth between a function and its reference point. More efficient in handling data tables, they reduces the length and complexity of a program. Sometimes they also increases the execution speed. There are three things which are associated to a particular location: name of the variable, content or value of the variable, and address of the variable. In memory, every storage data item occupies one or more contiguous memory cells. The number of memory cells required to store a data item depends on its type. Different types of variables will occupy different storage space. Whenever we declare a variable, the system allocates memory locations to hold the value of the variable. For example, you can consider these statements. Int a will allocate a memory like this, and this is the job of compiler to allocate a particular memory location. For example, for variable a, compiler has allocated 21345 memory location for the variable a, and here we have assigned value 5 to a. So 5 is stored in a is the name using which we can access this value, and 21345 is the memory location. Now consider this code segment. Int xyz will allocate a memory location for xyz. This is the memory location for xyz. And a variable p, which is a pointer variable and is capable to store address of any other variable of integer type. This statement will allocate 50 into xyz, and this statement will store the address of xyz into p. This is called the address operator, which will access the address of variable xyz. So here you can see that p equal to xyz is storing the address of xyz in p. These variables that hold memory addresses called point. So here variable p is a pointer variable by placing a asterisk before that variable. A pointer is just a C variable whose value is the address of another variable. Int ptr. For example, as we have done here, p equal to ampersand xyz. Here we have stored the address of xyz into p. Or it can be declared to allocate room in memory for something new that it will point to. We will see in the coming slides. Now consider this small code segment. Here the first statement is declaring two variables, an integer variable x which can store value, and a pointer variable which can store address of any other integer variable. Now this statement is allocating 5 in x. So here we have declared two variables x and p, and in x we have stored 5 using this statement, and this is a pointer variable which is capable to store address of any other variable of integer type. Now p equal to ampersand x will store address of x. This I am again telling you that ampersand is an address operator. It will fetch the address of x, and this statement will store address of x into p. So address of x is 1380. This address is being stored in p. Now printf, p will print the content of p. Here you can see that content of p is 1380. That's why it will print 1380. Now the second statement, ampersand x will print the address of x, which is again 1380. Address of x is 1380. Now the next statement is print asterisk p. Asterisk p will print the value of the variable which is pointed by p. Listen again. Asterisk p will print the value which is being pointed by p. Here you can see that p contains 1380. It means this p variable is pointing this memory location x, and content of that x will be printed out, that is 5. Asterisk p equal to asterisk p plus 1, it will fetch the content of the variable which is pointed by p, and it will increment in that variable. So this expression will increment this value 5 by 1. So this value will be 6 now. Now printf x will print 6 because this value has now become 6. printf asterisk p will again print the content of x because x is the variable which is pointed by p. Now how we can access the addresses of a variable? The previous example, p equal to ampersand xyz will fetch the address of xyz and assign that address into p. So the address of xyz, for example 1380, is assigned to p. The ampersand operator can be used only with a simple variable or an array element. For example, here you can see that ampersand distance will fetch the address of variable distance. Ampersand x of 0 will fetch the address of first location of an array named x. Here also you can see that this ampersand xi minus 2 will fetch the address of I minus second location of array x. These are the illegal use of ampersand operators. For example, if you place ampersand operator before a constant, it will not give you anything because ampersand operator is meant to find address of a variable. If ARR is an array, then also you cannot use ampersand operator for array. Similarly, you cannot use ampersand operator for an expression. For example, a plus b is an expression and you cannot fetch address of this particular expression because a and b both are independent variables and this expression is denoting the sum of those two variables and that sum is not being stored anywhere, so you cannot fetch address of that variable. You can consider this example. Here we have declared these many variables and these are the values which are assigned to these variables: a equal to 10, b equal to 2.5 and so on. Here you can print these values. A will print content of a, means the content of a is 10. Ampersand a will print address of a. So wherever compiler has allocated the location for variable a, that location will be printed out, the address of that location will be printed out. Similarly, it will print the content of b and address of b, content of c and address of c, content of d and address of d. Similarly, content of ch and address of ch. This is the output. These are the values which are being printed and these are the addresses, corresponding addresses. These answers may not be matching with your output on your machine if you run the same program on your machine because these locations are machine dependent. Okay. Here we have declared two pointer variables, asterisk count and asterisk speed. Once a pointer variable has been declared, it can be made to point to a variable using an assignment statement like this. Suppose you have declared a pointer variable p and an integer variable xyz, then you can assign the address of xyz into p, and this is called pointer initialization. Once a pointer has been assigned the address of a variable, the value of the variable can be accessed using the indirection operator. Asterisk is called indirection operator. Consider this code segment. I have declared two variables a and b and one pointer variable asterisk p or indirection operator p, and then p equal to ampersand a, it will store address of a into p, and b equal to asterisk p, it will store content of the variable which is pointed by p into b. So content of the variable which is pointed by p is actually a, so b will have the value which is pointed by a. So this statement is equivalent to b equal to a. Now consider another example. We have declared these variables, two integer variables and one c equal to 5 and another pointer variables. This statement a equal to 4 into c plus 5. So this c is 5, so the value of a will become 40. Now you have assigned the address of c to p, means address of c will be stored to p. Okay, p is a pointer variable. B equal to 4 into asterisk p plus 5. Asterisk p is the value of the variable which is pointed by p. C is here you can see that c is being pointed by p, so the value of asterisk p will be the value of c. Okay, so here when you print the values a and b, both will print the equal values, that is 40. This is another example which will make your concept clear. We have declared two variables x and y. Here you can see that we have declared two variables x and y and one pointer variable ptr. Now x equal to 10, it means 10 is being stored in x. Ptr equal to ampersand x, it means the value, it means the address of x is being stored in ptr. The address of x is this is being stored into PTR. Here you can see that this is being stored into PTR. Now y equal to asterisk PTR. Asterisk PTR will fetch the content of variable which is pointed by PTR. PTR is pointing x. So the content of x is 10. So now the 10 is being assigned to y. So the value of y is also 10 here. Now if you print these values x and ampersand x, x and ampersand x, asterisk ampersand x and so on. So x will print 10 obviously, ampersand x will print this value which is the address of x, asterisk ampersand x will give you the value which is pointed by this particular address. See this particular address, this is the address of x, and this is the address of x, and asterisk will print the content of this address. It means it will also print 10. Asterisk PTR will also print 10 because PTR is pointing x and content of x is 10. PTR will print content of PTR. Okay, so now PTR will print this particular value because this is the content of PTR. Understand it clearly that asterisk PTR will print the value which is pointed by PTR, that is the value of x which is 10. PTR will print the content of PTR. Content of PTR is this. This is the value which is pointed by PTR and this is the content of PTR. So asterisk PTR will print 10 and PTR will print 32212249004. Next PTR and ampersand PTR. PTR will obviously print the content of PTR and ampersand PTR will print the address of PTR, that is this address. Okay, this is the address of PTR. Now y will print the content of y, that is 10, ampersand y will print the address of y, and that is this. Now asterisk PTR equal to 25. Asterisk PTR is the location pointed by PTR, that is x, and you are assigning 25 into their location. It means you are storing 25 at x. So now if you print x after this statement, it will give you 25. So this is the output. 10 is stored in the location. This location is 4908. Here you can see that this is 4908 and this value is asterisk ampersand x. So asterisk ampersand x is which value? Ampersand x is this value, and asterisk will print the value which is pointed by ampersand x. So the value which is pointed by ampersand x is again 10. So here you can see the output is 10. Next is ampersand x will give you this particular value. Here you can see that this is the value. Okay, now consider this value. Asterisk PTR is the location which is pointed by PTR, that is this location x, and ampersand will fetch the address of this value, that is 4908, this location. So here you can see fourth statement. In the fourth statement you can also see 4908. Okay, so here is I think now the output is clear. Finally you can see that the value of x is 25. Now there are some expressions which are using pointers. So here P1 and P2 are the pointer variables. You can obviously add these two values. Now asterisk P1 is the value pointed by P1, asterisk P2 is the value pointed by P2. These two are the values, and you can add two values, there is no problem. Similarly, you can find product of these two values. Obviously these are the values pointed by P1 and pointed by P2. You can always find a product. Similarly, this statement can also find the product of these two content of P1 and content of P2. And here you are adding 2 to the content of the variable which is pointed by P1. Okay, so all these statements are valid. This statement is also valid because you are dividing the value pointed by P1 by the value which is pointed by P2, and after the result is being added with 5. So this is also valid statement. Which are the operations valid for the pointers? So you can add an integer to a pointer, subtract an integer from a pointer, subtract one pointer from another. This operation is also possible. You can find the difference of two addresses. If P1 and P2 are both pointers to the same array, then P2 minus P1 gives the number of elements between P1 and P2. Okay, if P1 is one address and P2 is another address, if you find the difference P2 minus P1, it will give you the number of blocks which are in between these two addresses. But these operations are not possible. Remember, the difference of two pointer variables are possible because that difference will give you the number of blocks between the two addresses. But sum of two pointer variables are not possible because you are getting nothing. If you add two pointer variables, it will just give you another. Addition of two pointer variables is not possible. Similarly, division of a pointer variable by another pointer variable or by a constant is not possible. Difference of two pointer variable is possible, but in this expression you are multiplying P2 by 10, which is not allowed. You cannot multiply a pointer variable with any other pointer variable or with a constant. We have seen that an integer value can be added or subtracted from a pointer variable. Okay, you can add a constant value to a pointer variable. You can add an integer to a pointer variable. P1 plus 1 is possible because it will give you the next block of P1. P1 plus j is also possible because it will give you the jth block after P1. Okay, I told you earlier that the addition of two pointer variables are not possible because you cannot do P1 plus P2, but adding an integer to a pointer variable is possible. If you write P1 plus 5, so that expression will give you the fifth block after P1. Okay, so adding an integer is possible, but adding two pointer variables is not possible. P2 plus plus is also possible because it is equivalent to P2 equal to P2 plus 1. So you are adding one integer into a pointer variable, which is possible. This statement is also possible because you are adding, because I and j are integer, and I plus j will also be integer, and P2 minus an integer is possible. These are the scale factor, means the block size. If the pointer variable is of character type, then the block size will be 1. If it is of integer type, then the block size will be 4 or 2. It will depend on the machine. It will not be true for all the machines. Float is of 4 bytes, double is of 8 bytes. If P1 is an integer pointer, then P1 plus plus will give you the address of the block which is 4 bytes ahead of the P1. So it will increment the value by 4 if the integer size is 4. The exact scale factor may vary from one machine to another, as I told you earlier. You can fetch the scale factor or the block size using size of function in C. So size of function can be used like this, as you can see in the next example. So this statement, size of int, size of float, double and character, all these print statements will print the size of these data types. Okay, so here you can see that size of integer is 4. I am again telling you that it will depend on the machine in which you are working. So integer is 4, float is 4, double is 8 and character is 1. Now pointers are often passed to a function as an argument. Pointer can also be passed as an argument, as you can pass values in the function. Now this allows data items within the calling program to be accessed by the function, altered and then returned to the calling program in altered form. This is called call by reference, means, or it is also called call by address or call by location. Using call by reference or using pointers, you can access any location. You can access any location no matter where that variable has been declared, whether the variable is within the scope of the function from where you are calling or not. Normally arguments are passed to a function by value. The data items are copied to the function. Changes are not reflected in the calling program. As you can see, this is very good example for understanding the importance of pointer. Here we have declared two variables a and b, a equal to 5, b equal to 20. Now we have made a function swap, and this function is meant to swap these two values. Okay, so after that I am printing printf a and b. So when we are this is the function definition. Here what we are doing, we have just swapped the values of these variables. Okay, so t equal to x, x equal to y, y equal to t, and after that we are expecting that values of a and b will be swapped. Okay, so now let us see the output. But here you can see that output is what? It is not changing. You can see before the execution of this statement the values of a and b are 5 and 20 respectively. Even after the execution of this function there is no change in those values. You can see in the output that values are not swapped. A is still 5 and b is still 20, which were the values as taken initially. So even after the execution of swap function, the values are not swapped. So why it has happened? So what we have done actually, we have declared two variables a and b, stored 5 and 20 in these variables, 5 and 20, and now we have called swap function. This is the swap function, and this function is also having two variables x and y. Okay, now when we are calling this swap function, the values of a and b are being copied to x and y respectively. So this value 5 will be stored in x and 20 will be stored in y. Now after execution of this code, these values will be swapped here in x and y. These values are swapped only in x and y. But when after execution control returns back to the main function the values of variables a and b, which are still 5 and 20. So you can see that values are not swapped here. Now we have rewritten the same program using pointer. Here instead of passing the values a and b to the function, we are passing addresses of a and b. So what we are doing, we have declared two variables a and b. But here in place of a and b, we are passing address of a and address of b to these functions, because these are the addresses, ampersand a and ampersand b are the addresses. That's why we have to declare these x and y pointer variables, because we want to store addresses in these pointer variables. So that's why x and y are declared pointer. So what is happening here? We are passing address of a and address of b to x and y respectively. So address of a is 1380, it is being stored here in x, and similarly address of b is being stored here, which is 1356. Okay, so now this function is executing. Now what this function is doing, in t there is a third variable t. Now you are storing the content which is pointed by x. Now we are not swapping the values in these variables, we are accessing the variable which is pointed by x, which is this. Okay, now t is that variable, asterisk x, and asterisk x equal to asterisk y. So asterisk x is this location, asterisk y is this location. So these values are swapped. So 20 will come here, this will be 20 and this will be 5. Okay, so after execution of this statement the values are changed in the original locations a and b, and you can see in the output that value of a is 20 and value of b is 5. Okay, so that's all for today. Now